Welcome to our show. Today we're diving into a fascinating topic that's sure to blow your mind. Have you ever wondered how much the Earth weighs?
That's a great question. It's something that many people have pondered, but it's not as straightforward as you might think.
Really? Can't we just use a giant scale or something?
Well, that's a common assumption, but it's not quite that simple. Before we tackle the Earth's weight, let's start with something more familiar: how we measure our own weight.
Oh, that's easy. I just step on my bathroom scale every morning.
Exactly. And have you ever thought about how that scale actually works?
Not really. I just step on it and read the number.
That's what most people do. But there's actually some interesting science behind it. When you step on a traditional bathroom scale, you might feel a slight dip. That's because there's a spring inside that's being compressed by your weight.
Oh, I've never noticed that before. So the spring is what measures my weight.
In a way, yes. The more the spring compresses, the further a pointer moves on a dial, indicating your weight. Even electronic scales use a similar principle, just with a much stronger spring that you can't feel moving.
That's fascinating. But how does this relate to weighing the Earth?
Well, that's where things get tricky. You see, we can't just make an enormous scale and put the Earth on it.
Why not? Is it just because it would be too big to build?
That's part of it, but there's actually a more fundamental reason. Even if we could build a scale that big, it still wouldn't work to weigh the Earth.
Really? Now I'm really curious. Why wouldn't it work?
To understand that, we need to look at different types of scales. We've talked about spring scales like your bathroom scale, but there's another type called a lever scale.
A lever scale? What's that?
Lever scales are what you might have seen in old markets or in science labs. They work on the principle of balance, kind of like a seesaw in a playground.
Oh, I think I've seen those in movies set in old times.
Exactly. With a lever scale, you put the object you want to weigh on one side and then add known weights to the other side until it balances. When it's balanced, you know the object weighs the same as the total of the weights you've added.
That sounds pretty clever. So why can't we use either of these types of scales to weigh the Earth?
Well, here's where it gets really interesting. Think about astronauts in space. Have you ever seen videos of them floating around in their spacecraft?
Yeah, it looks like so much fun.
It does, doesn't it? But the reason they float is because they're weightless in space. If an astronaut tried to use a scale in space, they wouldn't get a reading. On a spring scale, they'd just float above it. On a balance scale, they wouldn't make either side go down.
Oh, I see. And the Earth is floating in space too, right?
Exactly. The Earth is essentially floating in space, just like those astronauts. So even if we could make an enormous scale, we couldn't use it to weigh the Earth because it's not being pulled down by anything.
Wow, I never thought about it that way. So how do scientists figure out the Earth's weight then?
That's a great question. Scientists had to get creative to solve this problem. They couldn't use traditional scales, so they had to come up with other methods.
That sounds like quite a challenge. Do scientists often face problems like this?
Absolutely. In fact, that's a big part of what scientists do. When they face difficulties, they don't give up. Instead, they find creative ways to work around the problem and achieve their goal.
That's really inspiring. So in this case, they had to find a way to measure the Earth's weight without using traditional scales?
That's right. They needed to think of a method that doesn't rely on the Earth being pulled down by gravity, since the Earth itself is the source of that gravity.
This is all so fascinating. It really makes you appreciate how complex and amazing our planet is, doesn't it?
It certainly does. The Earth, floating in space, too big to be weighed by any scale we could build. It really puts things in perspective, doesn't it?
It really does. And it's amazing how something as simple as weighing ourselves can lead to such deep scientific questions about our planet.
Absolutely. It just goes to show that there's often more to everyday things than meets the eye. Science is all about asking questions and finding creative ways to answer them.
Well, this has been an eye-opening conversation. Thank you so much for sharing all this fascinating information with us today.
It's been my pleasure. I hope this discussion has sparked some curiosity in our listeners about the world around them and the scientific process.
I'm sure it has. And remember, folks, Next time you step on your bathroom scale, think about the Earth floating in space. It might just make that number on the scale seem a little less important.